What's up, Chem peeps? Let's do some stoic practice. In the combustion of methane gas, CH4, with oxygen gas, carbon dioxide and water vapor are the only products. How many moles of water vapor are produced upon the combustion of 4.0 moles of methane gas? Alright, in order to do any stoichiometry problem, we need to have a balanced chemical equation. We're combusting methane gas with oxygen gas. Don't forget your diatomics. Carbon dioxide gas and water vapor are produced. To balance this equation, I need to add a coefficient of 2 in front of my water and a coefficient of 2 in front of my oxygen. Boom. Balanced chemical equation. Now I know the mole ratio between my reactants and products. For every 1 mole of methane I want to react, I need 2 moles of oxygen gas, and I'll form 1 mole of carbon dioxide and 2 moles of water vapor. How many moles of water vapor are produced upon the combustion of 4.0 moles of methane gas? Alright, for any stoichiometry problem, you always want to start with the amount that you're given. In this case, 4.0 moles of methane. Boom. Set up your conversion factor. I'm going to carry down moles of methane so that unit cancels out. On the top, I'm going to put moles of water vapor. Now, what's the relationship between moles of H2O and moles of CH4? According to our balanced chemical equation, for every 1 mole of CH4, I'll make 2 moles of water. I don't even need a calculator here. 4.0 times 2 divided by 1, I'm going to make 8.0 moles of water vapor. Boom. Couple of things to keep in mind. Notice that my units of moles CH4 will cancel out, leaving me with moles of water. Also, be cautious with sig figs. My number of sig figs in my final answer has to match the initial number of sig figs that I started with. I'm not going to worry about these numbers 1 and 2 when it comes to sig figs. And then finally, always go back to your balanced chemical equation to see if your answer makes sense. How does water relate to methane in the balanced chemical equation? How does 2 relate to 1? 2 is double 1. So however much methane I react, I'm going to get double the amount of water. Oh, math. Done.